All right, so today let's learn how to solve this again. Another very beautiful question. Making 9 and 81 to have base 3, we'll have it at 3 will be equal raised to base 2 as 3 raised to power 2, 2y plus 1. Working on 81 can be 3 raised to power 4, open brackets, y minus 2 all over 3 raised to power y. Alright, so raised to power y. The next thing you need to do is to work on the right hand side. Write it horizontally. So we have it as 3. If we send the 2 inside, you have 4y by now plus 2 equals to 3 raised to power, send this other 4 inside as well, 4y minus 8, okay, divided by 3 raised to power y. Okay, so what we need to do is to apply law of division by subtracting the powers. We have 4y minus 8 minus y. Okay, then if we simplify the powers, you have 4y plus 2 equals to 3 raised to power 4y minus y will give you 3y minus 8. Then the bases will leave. You have 4y plus 2 equals to 3y minus 8. If you collect like terms very well, you have 4y minus 3y equals to minus 8 minus 2. Therefore, our y minus 2 or y will surely be equal to minus 10. Alright, so that's the answer. That's how you solve that problem for y. Thank you. I hope you enjoy the content. Give it a thumbs up, click the like buttons for me, please. Consider subscribing if you like the channel. Thank you. See you in my next video. This is Tam Barry. I am out. Okay, so let's learn how to solve this. Still in indices, most of those common jam questions. So what do we do here? Now, this 5 raised to power x plus 1, we are going to reverse this to be 5 raised to power x times 5 raised to power 1 plus 5 raised to power x equals to 150. Alright, so now we are going to define, say, let 5 raised to power x be equals to y. On that note, we'll now have y times 5 raised to power 1, which is the same thing as 5 of course, plus y equals to 150. We know that 5 raised to power 1 is the same thing as 5, so 5 times y is what we'll now finally have, equals to y equals to 150. Now collecting like terms, we have it that 6y equals to 150. Okay, and continue dividing both sides. We have 6y over 6 equals to 150 over 6. Of course, 6 goes into 150, 15 rather, will give you 2 times. Remember 3 added to 0 becomes 30. 6 going to 30 will give you 5. So y is equal to 25. That's the value of y for the equation. I hope you understand. If you don't, you can rewind and get further clarification. Okay, so that's the value for y, but we are not done, because we said let y 5 raised to power x be equal to y, and we have it now that 5 raised to power x is now equal to 25. Of course, from what we know, our x must be equal to 2. So that is truly the value of x that will be raised to power 5 to get 25. Hope it's clear now. Alright, so thank you for watching. Continue with other examples too. Okay, let's look at solving some questions involving simultaneous linear equations involving indices. So like we already know, let's apply law of same base. So let's make the base is already the same in the first expression. So we have it that for 5 raised to power x plus 2y equals to 5. This is going to be raised to power 1, of course. 5 raised to power 1, so the bases will cancel out. Powers will be equated to each other, and this is what we'll get as equation 1. Alright, x plus 2y equals to 1. Now, to design equation 2, we have to work on 4 raised to power x plus y equals to 16. Our 4 will be raised to power 2. 2 raised to power 2, that's 4. Then we express 16 as well as 2 raised to power 4. The bases can now leave, so we'll now have 2. Okay, we can divide both sides by 2, but we'll have 2. Let me write it down first. 2 equals to 4. That's 2 open bracket x plus 4 equals to 4. And that can be simplified further by dividing both sides by 2, so that we can reduce the bulkiness of the equation. So we'll have x plus y equals to 2. So this becomes our equation 2. Alright, so equation 1 and 2 are going to be solved simultaneously. Now, equation 1 was x, if you can remember, plus 2y equals to 1. And equation 2 is x plus y equals to 2. So how do we solve this? I think we can basically add up, subtract the two fractions, the two equations. Subtract equation 1, 2 from equation 1. We have it that x minus x will cancel out. Then 2y minus times plus will give you minus. So 2y minus y will give you y. Then 1 minus plus, minus times plus here will give you minus. So 1 minus 2 will give you minus 1. Now, to find x, we can use equation 2, which is x plus y equal to 2. And x will be equal to 2 minus y. Of course, x is equal to 2 minus 1. That gives us minus times minus is plus, so 2 plus 1 will give you 3. So obviously the value of x is equals to 3 and y is equal to minus 1. So those are the values of the variables. Let's check another example. Alright, once again, let's learn how to solve these simultaneous linear equations involving indices. So from the first equation, we work on the right hand side, expressing 32 as 2 raised to power 5. The basis will leave, and you have x plus y equals to 5. That becomes our equation 1. Then working on equation 2, so you have 3 raised to power 3y minus x equals to 3 raised to power 3, that's 27. Basis will leave. I will now have 3y minus x equals to 3. If you rearrange that correctly, you'll have x minus 3y equals to minus 3. X minus 3y equals to minus 3. So that will be our equation 2. Alright, so we are solving equation 1 and 2 simultaneously. Let's get them closer. Equation 1 is x plus y equals to 5. Equation 1. Equation 2 is x minus 3y is equal to minus 3. If you subtract the two equations, you have it that x minus x will give you 0. Then y minus 3y will give you 4y. Then minus times minus will give you plus. 5 plus 3 will give you 8. Obviously, our y will be equal to 2. Now, to find x, we have it that x plus 2 is equal to 5. Using equation 1, x plus 2 equals to 1. That tells you that our x must be equal to 3. Alright, so that's how you solve for that. So x is equal to 3, y is equal to 2. These are the values of x for the simultaneous linear equation involving indices. Thank you for watching. See you in my next video. This is Tambari. Don't forget to click the like button and subscribe if you like the channel as well. Bye.